Okay, so here we have a GCSE exam question, which is asking us for knowledge of proportion, so ratio and proportion. Let's immediately have a look at the examiner's remarks. The examiners say that part A actually was well answered, so that's good, but a common error in part B was to do with rearranging, so writing k equals 8 over 3, having correctly given 8 equals k over 3. And so what should have happened here? K divided by 3, well that 3 then should have multiplied both sides to give us k equals 8 times 3, which is 24. So a problem with rearranging equations here more than anything. Okay, so let's try and work through an answer to this. If you want to pause the video at this stage, give it a go yourself, then a good time to do that would be now. Okay, so all tickets for a concert are the same price. This means that we're going to have direct proportion. Okay, so that statement there tells us that everything's in proportion, and it's going to be direct proportion because presumably as the number of tickets go up, then the price goes up. So it's direct proportion. Because if one thing goes up, then another goes up. That's called direct proportion. Okay, and we know that when something's in direct proportion, we have two things. We have one variable multiplied by a constant times the other variable. So we're going to get something like that. Okay, so now let's have a look at the question. Amy and Dan pay £63 altogether. Let's circle that. And Amy pays £24.50. So the first thing is we don't know what Dan pays. So let's work that out straight away. Okay, so Dan, if we go over to one side here just to work this out, must pay £63, subtract £24.50, which gives us 0. If we need to just borrow here. Okay, so now we've got £38.50. And I think it's worth just double checking when you've done something like this that £38.50 added to £24.50 will take you back to £63. So let's just check that. So 0, 1, and so we got, that should be a 4. So we've got 13 and 6. So that takes us back. So that's just our little check. Okay, so this must be right, which means we can now fill in Dan pays £38.50. Just make a note of it there. Okay, now Amy pays £24.50 for 7 tickets. So for £24.50, £24.5, you get 7 tickets. So if we think of this as x and this as y, then our x to y ratio is 24.5 to 7. Okay, so we should get the same proportion with Dan, but we only know for Dan the x value. So in other words, 38.5. What we don't know is the y, so in fact we might as well give that the unknown variable y. Okay, so we're trying to find y because we want to know how many tickets Dan buys. How do we do that? Okay, well the first thing we want to do is find this k, this constant that always works. And the way to do that is, again, if we go to one side, we can use Amy's ratio here. So this is Amy, and this is Dan. So we can use Amy's ratio to plug in values for x and y. So for Amy, we've got y is 7. So y is 7. And that must be equal to then k, which we don't know. We'll put that at the end. Times x. Well, x is 24.5. So that little formula there will give us a value for k. Let's rearrange it then to get k equals. So we've got k, so let's put therefore k equals, divide both sides by 24.5 and we get 7 over 24.5. And what I'm going to do is double this to get rid of the decimal, so I've got 14 now over 24.5 times 2 gives us 49. And that simplifies. Highest common factor is 7, so 14 divided by 7 is 2, and 49 divided by 7 is 7. Great, so now we've got 2/7 as our scalar, k, and so I'm going to use that now to figure out how many tickets Dan gets. Well, just using the same formula here, y equals kx, I've got y, which I don't know, equals 38.5 times k, which we now know is 2/7. So times 2 divided by 7. And so 38.5 times 2 is going to give me 77. Divided by 7 then. And 77 divided by 7 is 11. So therefore y equals 11 tickets. Okay, so that completes part 1. But what I want to do just before I move on, maybe you would do this at the end of an exam, but just before I move on, I just want to use an alternative method to give this a quick double check. Okay? So another way to think about this is as a fraction. Okay. Let's just raise this little marker. Okay. So as a fraction, we've got 7 y over 7, okay, equal to, let's just call this, just make it clear that this is a check, y over 7 is equal to 38.5 over 24.5. And I could have used different comparisons, but this should work. So just as a quick check, now if I now multiply both sides by 7. In fact, I think it might be easier if I double this to start with. So instead of 38.5, I'm going to double 38.5 to get 77, and double 24.5 to get 49. I've got much nicer numbers to deal with now. Okay, so now I've got y over 7 equals 77 over 49. So then I can say multiply both sides by 7 and I'll get y equals 7 times 77 over 49. Like that. Okay, so that should be a 7. Now, instead of multiplying that and then dividing by 49, much easier if I divide top and bottom by 7 straight away, and otherwise I cancel that 7 and cancel that to become 7. I divide that by 7 to become 7. I've now got 77 divided by 7, which is 11. So that gives me my check that 11 tickets must be correct. Okay, part B. Now for part B, we're told that y is inversely proportional to x. Therefore, y must equal 1 over k x. Or in other words, sorry, not 1 over kx. Let's see, not 1 over kx. K over x. Okay, So that's the way to do it. So that x becomes a divisor, in other words, the denominator of a fraction with k the multiplier. Okay, so y equals some multiplier k divided by x. So what I can do is rearrange that straight away so that I get k equals, if I multiply both sides by x, I will have x times y. So k equals x, y. So what have I got to do? Now, when x equals 3, y equals 8. So 3 to 8. So I've simply got here x and y, no Amy and Dan type scenario anymore. So 3 to 8. And with this problem here, I've got, so equals 5 to y. But what I've got to remember is these are inversely proportional. So it doesn't work in quite the same way as it did up here, and I need to just think about that, especially when I try to check. So here's my x and here's my y. The y is what I don't know. Anyway, now I've got this formula, I can simply use that formula. So I want to find k to start with. Well, x is 3, y is 8, so I can simply find it by substituting into this rearrangement here. X is 3 times y, which is 8. So k is 3 times 8, which is 24. And now using this original formula, y equals k over x, I can substitute my 5 in to get 5. Let's do it here. So 5, sorry, not 5, y is my y value. Okay, so I get y equals k, which is 24, divided by x, which is 5. That's it. Okay, like that. So how many times does 5 go into 24? Well, 5 goes into 24 times, and then I've got 4/5. So my answer will be 4. Let's use a decimal, 4.8 then. But let's check, make sure that we didn't make some sort of slip up there. That seemed to work very nicely, but let's just check. And we can check, as long as we remember it's inversely proportional, by saying, well, okay, so we must have, let's see, 8 y over 8, yeah. Let's have another go. So 3, it's very easy to get confused with these things. So 3 over 5 is the same as y over 8. That must be right. Let's just check. 3 over 5, so that's going in that direction, so 3 over 5, and now we want to go in this direction to get y over 8. Yeah, that's correct. So now I've got this formula here, which is giving me my simple check. It's a little trick really, just to check that this is the right answer. So now I need to rearrange it. So if I cross multiply, I will get 3 times 8, which is 24. So 24 equals 5 times y, 5y then. So y equals 24 divided by 5, which is exactly what I got here. So my answer again is 4 4/5. So this must be correct.